Hey there, today we're going to present to you a work that we have developed at the LASS lab. LASS lab is a lab focusing on computing and network, and we have made the MonTh tool, which is a tool for automated monitoring of threads. And here we go. So we have our summary. Our summary are split on 4 sessions, and we have the first one, and we gonna start it for this. So in the recent years, we have a significant increases in cyber attacks on the companies and government system. So this creates a challenge, which is with intelligent threats currently manual or semi-automatic, requiring automation for efficiency. And it is important of protecting data and services online in a complex digital environment. So for this, we propose the month though that this automates the monitoring of malicious IPs from various sources, updates with emerging threats, process and structures data in a inclusive way. So we focus on identifying malicious IPs as potential threats. So here we have a cyber threat intelligence which collects and interprets data to prevent, detect, and respond to cyber threats. And the rule to implement a cyber threat intelligence program are described below. And in this picture below, we have some cycle which presents the 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 mind flow of creation and application of a cyber threat intelligence program. We have the first one, which is the plan creation, and in this phase, we develop a comprehensive plan for cyber threat intelligence, and then we have to identify the stakeholder, identifying the key user of threat intelligence with the organization and or some target. Then we have the expected information. We have to assemble a specialized team to this task, and then we apply the TTP implementation, put in a necessary tools, techniques, and procedures for gathering intelligence, and then we have finally the data differentiation. So here we have some description of the tool, and this description is an introduction of the tool, which is named automated monitoring of threat bases. So the acronym of MonTh. The MonTh collects data on malicious IPs from various threat bases, and the data is collected from some threat bases to build a vector of 31 features. The activities of this tool includes the base crawlers, which is implemented in it, data processing, feature extraction, emerging base basis features. So this uses a dynamic approach to build this vector of features and merge the data from the statical way from these databases in a dynamically way from this database too. So we're gonna explain a little bit more about this dynamic features in the next slides. So for the stack, We utilize the Fast API for APIs, the Seaborn for visualization, and Pandas and NumPy for data manipulation and plotting, and a Docker for MongoDB and GIX, and Celery for infrastructure. So here I have a picture that in this picture we have mapped some technologies that we use it in this tool. We have used the scikit-learn libs for AI algorithms. We have used the Fast API for programming interface frameworks, and the Docker for the infrastructure. Here we have a little deep understand of the input of the output of the application. This is the vector of features, and in this vector we have some example of registering an IP feature vector before the data engineer process, and this data is collected from a public threat databases to build this vector of features, and this is a preparation process to transform this data in from a categorical data into a numerical data. And after, in the left side we have categorical data, in the right side you have the numerical data to be inputted in some AI algorithm and get some tracking of the behavior of the vector of features. Then in this section we have the experiments. Here we are able to see that the MonTh is configured to perform 4 times a day, monitoring 250 IPs for 2 months. The datasets obtained from IP blacklists, which can be from Tor projects, and whitelist that was from known companies in the world like Google, Apple, Microsoft, and so on. So some divergences among threat databases and the importance of understanding database specific metrics are are presented to you in these pictures, in the picture 1 and 2 to be more specifically, and the analysis of the relationship between the number of reports and distinct user are mapped in the next slides too. From this slide it's important to map that the behavior of the reputation score depending on the whitelist feature that was retired for the AIBZPDB whitelist. So it's possible to note that there is a large variation when comparing the Alien Vote reputation graph and the IBM score graph. So in this picture, and on the picture 3, we have some data tendencies, and in this picture represents correlation metrics between features. This feature reveals to us certain behaviors and concentrations of data features, examining the geographical metadata in each record as ASNs, ISPs, and so on. So this piece of information are crucial for identifying IP addresses that may be involved in a large-scale attack campaigns, where they are like to affect a significant number of victims. So this one is an important picture because it maps some data tendencies that tells to us that the variation of user can grows up the number of reports, the total reports. So the variation in the number of distributors depending on the variation in the number of reports. This correlation is a strong indicator that when an IP is involved in a suspicious activity, it tends to be reported by a diverse set of users. So, for conclusion and future work, we have that the MonTh tool automates threat updates, providing vital insights into IPs and suspicious domains. And it's effective in mapping it and building some global threat knowledge base. So for future works aims to expand analysis to cover URLs, some domains and files for deep threat identification. And that's it. Thank you for your attention. And doubt anything that you have to that you want to be tracking about our job, you can have contact with us at this email, and that's it. Thank you and see ya.